Statisticians! Welcome back. So I wanted to talk about these two formulas and what's actually going on in them, because even though these are on your formula sheets, you do need to understand the hieroglyphics. So of course, if you remember, sigma means that I'm adding up, and what I'm adding up is each individual data value. So each data value minus the mean. And then I'm taking a collection of these because each one of those differences is being squared. So notice I'm taking a difference, squaring it, taking another difference, squaring it, taking another difference, squaring it, and then I'm going to add them all up. And then for the sample, I'm going to divide by n minus 1, versus over here on the population, I'm dividing by n. Okay, so let's do an example on the next page. All right, so go ahead and do a quick calculation. You can use your calculator and find the mean for this data set. Hit pause while you find it. So hopefully you got 77.5. So now I'm going to take each one of the data values and subtract that mean, and then I'm going to square all of those. So it's going to look something like this. So here you'll notice I took every single one of the data values in the list and I subtracted the mean, and then I'm going to square them all out. This is what I'll get. So now a key feature to notice is that some of those values turn out negative. That's because some of the numbers are below the mean and some of the numbers are above the mean. So if I were to just add them up without squaring them, they would literally turn into 0 every single time. And then if I try to average it, obviously I'd get 0, which that would be very silly. So that's one of the reasons for squaring them. Okay, so I'm going to square it next, and it will look like, okay, so there's each of them squared. All right, so now I want to average, which means I need to add them all up, and I get a total of 573.5, and then I'm going to do both calculations, both the population one, which is sigma, and the sample one, which is the S sub x. So I'm going to be dividing that once by 6 and once by 5. So here's the population standard deviation. Notice I divided by 6, and now I'm going to do the sample, and there's my sample standard deviation. Notice the sample standard deviation is a little bit bigger than the population. And so here's a thought question for you. Is S sub x greater than sigma sometimes, always, or never? Think that over, and we'll have that conversation tomorrow and be ready to defend your answer. In addition to that, I want you to do the next problem and answer the think question below it. And we will check your answers tomorrow in class.